So in this video, I'm going to look at the Single Award Science Physics paper. This is Unit 3, and this one's the higher tier paper of the specimen papers that CCEA produced. It's 1 hour long and 60 marks for the paper. So here we go. First question, some sources of background radiation are shown in the table below. Put a tick beside each source which is caused by humans. So you have a choice: nuclear weapons, cosmic rays, granite rocks, and x-rays from hospitals. So nuclear weapons, definitely caused by humans. Cosmic rays come from the cosmos. Granite rocks are on the planet already, and x-rays from hospitals then have a human cause as well. Next, the bar chart shows radiation levels in different districts of Northern Ireland. We have radiation in arbitrary units. We have the districts here, so Belfast, Londonderry, Fermanagh and Uri and Mourne. So how much higher is the radiation level in Uri and Mourne than in Belfast, and show you're working out. So if we read across on the graph there for Uri and Mourne, we have 90, Belfast is 24, and so correctly reading them off the graph gets you 1 mark, and then doing the little calculation and getting 66 as your answer gives you your 2nd mark. Then we have a radioactive source which emits alpha, beta and gamma. Each type is stopped by a different material as shown below. So here's the source, then we have thin paper, an aluminium sheet and a lead sheet. And if you look at the numbers here, this type is 1, the one going to the furthest distance is 2, and this one is 3. So that's what might catch out in this paper, just not paying attention to where the numbers are. So which type of radiation is number 1 then? So it's stopped by thin paper, so that's alpha. Number 2 goes all the way to the lead sheet, so it must be gamma. And then number 3 is stopped by aluminium sheet, so that's beta. If you got 1 or 2, that was only 1 mark. All 3 for 2 marks. And the graph shows the power used by a washing machine when it's set to different temperatures. So we have the power in kilowatts here, the temperature setting in degrees C here. So describe the relationship shown in the graph above. So as temperature increases, power increases. 1 mark, so it's just showing a linear relationship here, and that's all you have to talk about. So the second part of the question, complete the diagram to show the useful energy changes that occur in a washing machine. So we have electrical energy going into the washing machine, and it tells you that one that's coming out is heat, and the useful energy then that's missing is kinetic, or you could have said movement, for 1 mark. Then we've got a picture of the plug here for the washing machine. It says it's connected to the 240 volt mains using the plug shown with a 5 amp fuse in the diagram below. So here's the fuse. And then use the graph in part A and the equation power equals current times voltage to calculate the maximum wash temperature this plug will allow. So first of all, we're using power equals current times voltage. So that is, well, the current is 5, the voltage is 240. I've written it the wrong way around there for that equation, but it does the same job. You get 1200 watts for your answer, or 1.2 kilowatts. And then if we go back to the graph and look at 1.2 kilowatts, it's coming in, just a second while it saves itself. So 1.2 coming in here. And then mark scheme allowed 60 plus or minus 1. So 3 marks for that, 2 for the first calculation, and then 1 for reading it off the graph. Next then we've got a graph showing the braking distance for a car and the thinking distance for a driver and how they change with speed. So we've got distance here, the braking distance, the thinking distance, and then the speed across the x-axis. So use the graph to describe one similarity and one difference between the changes in thinking and braking distance. So both of them increase with speed, but the difference is that the braking distance increases more or at a faster rate. So 1 mark for each of those. Then a car driver travelling along a road sees a child step on the road ahead. The driver's thinking distance is 9 metres. Use the graph on the previous page to answer the following questions. So what speed was the car travelling? So if we go back here and then look at the graph, so the thinking distance is 9 metres. So that is here, and that's coming in then at 15. That's not very accurate there, so it's coming in at 15. And there we go. And then calculate the car's total stopping distance, so it's 27. So we get there by then looking at the braking distance as well at that, which comes in at 12, so 10, or sorry, oops, malfunction, so 12 and 15 is 27. So then, apart from speed, state one factor that would increase the braking distance of this car and explain your answer. So you could say per road condition, per tyres, per brakes, and that would be for 1 mark, and then any of those would reduce friction or grip for your second mark. Right, this is a table which shows the percentage of each energy source used to produce electricity in 1973, 90 and 2007. It also shows the total amount of energy produced in these years. So here are the sources: hydroelectric, other, coal, oil, gas, nuclear, and then the total at the bottom, which is in terawatt hours. And then the different years here: 73, 90 and 2007. So name the fossil fuel that increased the most over these years. So when you look at the list, actually there are two which are pretty close. We have gas and nuclear, but it's actually gas which has gone up slightly more. Then during these years, the price of oil has steadily increased. What effect has the price made on the percentage of oil being used to generate electricity? So you can see here going from 24.7 down to 5.6%. So as the price increased, less oil was used. And it says the total amount of electricity generated significantly increased between 1973 and 2007. You see there it's gone from just about 6,000 terawatt hours to nearly 20,000, which is a huge increase. So any two of these reasons, you could have suggested it was because of a bigger population, or people using more appliances, or people using appliances for a longer time. Next bit is about fossil fuels. So explain fully how the fossil fuels were formed. So any two of these points, but you need to be talking about how the remains of plants and animals, which died and were buried over millions of years and under high pressure and intense heat, then formed fossils. Then, apart from hydroelectric, name another renewable energy source. Any of these, you'd have wind, solar, geothermal, tidal, or biomass. Now, we've got pictures of some light bulbs here, and it says the diagrams below show a filament lamp, a halogen lamp, and a compact fluorescent lamp, which is CFL. So this is the filament lamp. It has a wire inside. The halogen lamp is filled with argon, and then CFL is one of these sort of curly ones that you might have seen in your house. So the graph below shows how the light output for each type changes with power output. So we've got the light output here and the power output. So you see the CFL is the first one here, and then the halogen lamp is here, and then the filament lamp is this one on the outside. So it's just saving again. The questions then are going to be reading off this graph. So at 50 watts, calculate how much more light a halogen lamp produces compared with a filament lamp. So at 50 watts. Okay, so we're looking for 50 watts here, and it was comparing a halogen lamp with a filament lamp. So the filament lamp is here, and the halogen lamp is here. And if you read those two off, you'll see I've written them down here. We've got 900 for the filament lamp and 700 for the halogen, 900 for the halogen, 700 for the filament. Take those away, you get 200. Then it says state two trends shown in the graph on the previous page. So as the power increases, the light output increases. You can see that for all of them. Light output is increasing here as power increases there. Then the halogen uses less power than the filament to produce the same amount of light. Or you could say it's similar for the CFL and the halogen. Okay. Then use the graph and your knowledge to explain why the government is promoting the use of CFL bulbs and stopping the production of filament lamps. So CFL uses less electricity to produce the same light, and less fossil fuels are used, or it's more efficient. So 1 mark for each of those. 1 for using the graph and explaining, and then 1 for the suggestion of why. Question 6, use the diagram to answer the following questions. So we've got a circuit here, and you see there are bulbs, and it's labelled bulb 1 and bulb 4, and then different ammeters here, A1, 2, 3 and 4. So it says if the current flowing through ammeter A1 is 0.4 amps, what's the current flowing through A2, A3 and A4? So A1 here, I'm going to write this on, is 0.4. So when you look at this, the current flowing through A1 and A4 is the same, so that's also 0.4. So I've written that in. But then at A2 and A3, you see here the current has split. So half of it's going here and half of it's going here, so 0.2 for each of those. So if the batteries supply a voltage of 6 volts in total, what is the voltage across bulbs 1 and 4? So in this case, the voltage is splitting, so it's going to be 0.3 in each of those because that's a parallel circuit. Then the photograph shows a variable resistor, and I'm sure you've seen these in school and you've done experiments with them. So describe fully how a variable resistor controls the current flowing in a circuit. So you need to be saying something about the slider moving, changing the length of wire, and as the length of wire increases, the resistance increases, and then as the resistance increases, the current flowing decreases. So all 3 for 3 marks. Suggest one everyday use of a variable resistor. You could be talking about a dimmer switch or even a volume control. Then it says the graph shows a relationship between the resistance of a wire and its cross-sectional area or thickness. So there's resistance in ohms and then the cross-sectional area. Describe the relationship shown in the graph. Again, it's 1 mark, so it's just a simple relationship. So as the area increases, the resistance decreases, so it's going down. Name another factor apart from length and area which will affect the resistance of the wire. Well, the material that the wire is made from. Now we've got a question about heat transfer. It says explain fully how heat travels through solids, liquids and gases. Not very much information there, but you're probably looking at a couple of marks for each, and then I'll show you at the end where the marks actually come from. So if you're talking about solids, you would say conduction through solids because the particles are closely packed, so that would be 2 marks there. Then vibrations pass heat energy along through them. You could also say that metals are good conductors. And then talking about liquids and gases, so convection through liquids and gases. You could talk about convection currents, but as long as you're mentioning the word convection there with both liquids and gases, that's another marking point. And then if you're talking about hot liquids and gases are less dense, and then that means that the hot liquid or gas rises up from the heat, and that sets up a convection current. So any 6 of those points would get you into the 5 to 6 mark bracket. 4 to 5 would get you into the 3 to 4 mark bracket, and 1 to 3 would get you to the 1 to 2 mark bracket. And if you're using your written communication skills well, you're going to get the top end of each of those, so 6, 4 or 2 marks. Then the diagram shows 2 skydivers falling through the air before their parachute opens and the forces acting on them. So we have this going upwards, which is 1200 newtons, and going down we have 1200 newtons. So name the 2 forces acting on these skydivers. The one going down is obviously weight or gravity, and then the one going up would be air resistance or friction, so it's pushing against them as they're falling down. And then describe fully in terms of the forces the motion of these skydivers. Well, you see here they're both the same, the forces are the same, so that means they're moving at a steady speed due to the balanced forces. So 2 marks for that. Describe fully the effect opening the parachute will have on the forces acting on these skydivers. So very important that you realise that the weight of the skydivers stays the same. There's nothing being added to them, but the air resistance is going to increase because the surface area of that parachute is much bigger, and it's going to then increase air resistance. So weight is the same, air resistance increases. I've got a picture now of the International Space Station, which orbits the Earth at a height of 400 kilometres once every 90 minutes, or 1.5 hours, and at a speed of 5 miles per second. And of course it did when these papers were being written. So calculate how many times the ISS orbits the Earth every day. So we have every 1.5 hours, and there are 24 hours in a day, so 24 divided by 1.5 gives us 16 orbits in one day. And this is the last part of the paper here, so we've got another question about the universe. So in the Hertzsprung-Russell diagram shown below, each star is represented by a dot. The position of each dot in the diagram tells us two things about each star: its brightness and its temperature. So you see brightness here and then temperature, and the temperature is increasing from right to left here. So from 3,000 here to 30,000 there. So use the information on the diagram to answer the following questions. Estimate the surface temperature of our sun. So here it is. So you're reading it off the graph there, sort of between 5,500 and 6,000. And that's Kelvin, by the way, degrees Kelvin. That's the scale that goes down to absolute zero, as you know. So state two differences in the properties of Alpha Centauri b compared with our sun. So there's Alpha Centauri b there, and it is coming in at just, about here in the temperature. So our sun is hotter, and then if we look at the brightness, our sun is brighter as well. And then one way, our sun and Alpha Centauri are similar, so they're about the same size, okay, or they're a similar age. Then finally, describe fully the formation of the universe according to the Big Bang theory. So any three of these points would get you your 3 marks. So there was a huge explosion or expansion, and either way of saying it is just worth 1 mark. 14 billion years ago from a singularity. And then you could have said that scattered dust, gas and matter everywhere. So any three of those points, 3 marks. And then it says name a scientific alternative to the Big Bang theory, and that would be the steady state theory. So that's all of the higher tier physics paper. I've also done the foundation tier if you want to have a look at it too. There are some common questions, but yeah, join me again for other papers.